main pollutants. Now what I want to show you was our circle. Actually, this one won't work very good for our shape one. We're going to let that go for now. So we took our O2. We can still go back, class. See now? Got oxygen. Got the molecular orbitals coming together of the up and down electron spins. Come on, you stuffy professors. You can't deny this has an educational value to it. Because look, when they're the same, they don't stick, right? Molecular orbitals with the same spins, they're not going to occupy those energy states, right? Well, here it is. You got it. They got to be opposing. Comes together. And I'm sure there's one of you guys, smart Alex out there, sitting there going, you know, how are you going to do the triplet state? Well, anyway, they're learning their bonds, okay? O2 and H2 makes H2O. Water vapor. These are reacting up in the atmosphere. I'm going to show you here. Ultraviolet rays are hitting the upper atmosphere. Well, that's where ozone is. So ozone is O2 with another oxygen. That's 3 O's, right? Well, what we do here is we can tie these. We're going to just kind of do it for general purposes and hope that it holds for a second. This is an O2. Along comes another O2 that gets zapped by an ultraviolet ray up there. Dissociates, that means it splits the oxygen. And now what you're going to end up with is a double bonded oxygen. With a single bonded oxygen, there's going to be a lone pair of electrons out there because O3. This is ozone. Now how ozone protects you is, this was a great little exercise that we did. When these are half filled with helium, they float around the classroom. So I shot it out there, it stayed real high, the kid couldn't reach it, he's jumping on the seat, the class is laughing, but it just hovered up there. So I said, all right, wait till it comes down. Went to the board, drew out, because this is the reaction now. You've got O3 absorbing a UV ray. O3, ozone, plus ultraviolet, should have done that in violet, is going to react by absorbing that energy. It's going to make an O2 and an O radical. Again, see that electron out there is what makes a radical so energetic. Now, how's a kid going to remember this reaction? How are we going to be aware of how the ozone is protecting us? Here's ozone. When I floated that out to the class, what I do is I usually tie that one really good. So you got to picture this as being the single bonded O. That would be the double bond O. So one of the O's, kid hit it as hard as he could. He hit it too hard and absorbed the energy and didn't break. Little girl got up there, popped it. She didn't hit it hard enough. So I said that was an ultraviolet ray to X-ray was the hardest one. Ultraviolet to infrared was too light. So not enough energy was the infrared. The X-ray was too much. It's got to be just in the wavelength of ultraviolet to absorb that energy. So what happened? The person went, hit it just right. And what'd you get? Now, do you see the beauty of a good balloon? Did you see how good that was floating? So you can even do these. If you really blew them up, you got to really be careful when they pop, though, because they pop loud. So see here now, what's beautiful is these molecules will be floating around in the classroom. So what do we got so far? We got O2, H2, and O3.